Here's a couple questions from the Lesson 1 note package. So these were the textbook questions that were attached at the end of the note package. Question 8a is 6r squared p to the 3 over 4r p to the 4. So if you were solving this question, a few things that we would do. You would look at the 6 and the 4 and you would say, okay, how could you reduce this? So 2 goes into each of those numbers, and 2 goes into 6 3 times, and 2 goes into 4 twice. So 6 over 4, if you type that in on your calculator and hit math one fraction, that would reduce to 3 over 2. Okay, so this is simplifying. Then r squared over r to the 1. From Math 10C, this would be quotient law where you subtract the exponents. So r to the 2 divided by r to the 1 is simply r would be left over. But to show you sort of how that works is in the numerator I have 2 r's, and in the denominator I have 1 r. And what would happen is that r over r would simplify. And then I could do the same thing with the p's. I have 3 p's up top, and in the denominator I have 4 p's. And you could cancel a variable for a variable, right? So 3 p's in the numerator and 3 p's would cancel in the denominator. And what I'm left with is 1 p, and it's in the denominator. So my final solution would be 3 over 2. I've got an r in the numerator and a p in the denominator. And that would be my solution. My non-permissible values, r cannot be equal to 0, right? So going back to the original question, r cannot be equal to 0, and p cannot be equal to 0. So we could never have those variables being 0, because then my entire denominator would be 0, and we could never divide by 0. Before I go on to question B, I just wanted to show you another way from 10C how we would have done this. So in 10C, you would have said, okay, p to the 3 divided by p to the 4, that's p to the 3 minus 4, because remember for quotient law, we subtract exponents, that should be a 4. And that is equal to p to the negative 1. And then from 10C, how do you write that with a positive exponent? This was all over 1. And remember that when you bring your variable into the denominator, that negative 1 becomes positive 1. So that's the same thing as 1 over p. And that's why the p down here is written in the denominator. Okay, so that's question 8a. For question 8b, you always want to factor these questions, okay? So that's, you always, in order to simplify, you have to be factored. So 3x minus 6, what can you pull out of a 3x minus 6? You could factor a 3 out of there, so divide this by 3 and divide this by 3. So I'll show you over off to the side. 3x minus 6, if I factor out a 3, the 3 goes in front of the bracket and the solution goes in the bracket. So I would have x minus 2 in the bracket. And then my denominator, 10 minus 5x, I would say, okay, well, what can you factor out of that? And you could pull out a 5 from here. So the 5 goes in front of the bracket. And then what you would have left over is 2 minus x. Now, the brackets are not ready to be canceled yet. So what I'm going to need to do is I'm going to need to rewrite, if this has my variable first, I'm going to rewrite this bracket to have my variable first, okay? So my numerator was 3 and x minus 2, and my denominator is 5. And then I'm going to rewrite that 2 minus x to be negative x plus 2. From here, if ever you start with a negative, you could always divide out that negative. So I'm starting with a negative, there's a negative 1 there. I could divide from this bracket a negative 1 out. That negative 1 is essentially going to go in front of that 5. And what I would be left with is 3x minus 2 all over negative 5, When I factor out that negative 1, I am left with x minus 2. Now those two brackets cancel, so that would cancel with that, and my answer is simply going to be negative 3 divided by 5.